You are welcome to online lectures with Farmer the Schoolboy. Today, we'll take a look at pharmaceutical chemistry. Pharmaceutical calculations. Today, we'll take a look at pharmaceutical calculations. And is more of a revision for those preparing exams. Okay, so it will question oriented, so pick one or two questions, then solve and see how far we can go in 2 hours time. Once again, you're welcome. Okay, so let's get started. Please, if you have any question as we solve, feel free to call. Call this number 081-3868-2003. Call. If you have any question, feel free to call. Okay, let's start with the first question. This question is taken from the topic. Concentration, at the same time ratio and proportion. All right, the question says, pharmaceutical calculations. Okay. Excuse me. Okay. Okay. As you can see on the board, the question says, Clobex solution contains 0.05% weight in volume clobetasol propionate in 100 ml containers. Calculate the content of drug in milligrams. All right, solution. Okay. Clobex lotion is the dosage form. That's the medicine. Whereas clobetasol propionate is active ingredient. So clobetasol propionate is the active ingredient inside the what? The lotion. So, but the concentration is what? 0.05% weight in volume. 0.05% weight in volume. The volume of the container, that means the entire product, medicine, is 100 ml. So we are asked to calculate the content, that is the amount of the active ingredients in this lotion. Now the concentration is 0.05% weight in volume. So let us open up this concentration, what it actually means. 0.05% weight in volume is the same thing as saying 0.05 gram in 100 ml. That's the meaning. It means 0.05 gram in 100 ml. Now, but the entire container, the container is what? 100 ml. So this implies that we have 0.05 gram of clobetasol propionate in the products, in 100 ml of the what? The products. So if you take a look at this now, by coincidence, the container itself, the product itself is 100 ml. So if the product itself is 100 ml, so the answer is simply what? 0.05 grams. 0.05 gram is the content of the active ingredient, but we don't conclude yet. We are told to look for it in milligrams. So that means if the amount of clobetasol is 0.05 gram, we convert this 0.05 gram to what? Milligram. Remember that 1 gram is equal to what? 1000 what? Milligram. That means that 0.05 gram is equal to what? X. We make X the subject of the formula. So X, let's come over here. So X is now equal to, we will cross multiply 0.05 gram times what? Times 1000 milligram. All over what? 1 gram. Gram will cancel gram. 0.05 times 1000 milligram is, by implication, now this 1 decimal movement, 2 decimal movement. So this is 50 what? Milligram. 50 what? Milligram, because 0.5 is 500 milligrams. So 0.05 is 50 milligram. So we have 50 milligram of clobetasol propionate in 100 ml container. So the answer to this question is 50 milligram of clobetasol propionate. Now, let's look at the situation whereby sometimes you may feel that this looks so straightforward because the container is just 100 ml. What if the container is 200 ml? What are we going to do? So let's look at it. If the container is 200 ml, what it means is that if the container is 200 ml, see what this will look like. If the container is 200 ml, that means since we have 0.05 gram in 100 ml, how many, we call it X, will be in what? 200 what? Ml. So we find this S. This X will now becomes what? We cross multiply 0.05 what? Gram times 200 ml. All over what? 100 ml. So ml will cancel ml, 100 will cancel 200. We have 2. 2 times 0.05 gram. We have 0.1 gram. So that means X is what? 0.1 gram. So if X is 0.1 gram, we now move 0.1 gram to milligram. We replace 0.05 with 0.1 gram. So we have 0.1 gram times 1000 milligram. So gram will definitely cancel gram. So we have 0.1 times 1000 milligram, which is what? 100 watts milligram. 100 watts milligram. All right. So if you have any question on this, please feel free to call for explanation. If it's not clear, feel free to call. All right. So let's move to another question. Or let me give 1 or 2 minutes for question. Please ask your question. 2 minutes, then we'll go to the next question. Ask your question. Feel free. Just call 08138682003. We have 1 minute to go. The number is 08138682003. Ask your question. Okay, let's go over to the next question. Okay, let's look at this question. The question says, what weight of potassium permanganate is required to produce 500 ml solution such that 25 ml of this solution diluted to 500 ml gives a 0.025% weight volume solution? Now, to solve this question, we need to understand which one is the solute and which one is the solution. The solute there is potassium permanganate. That is solid. We are looking for the weight. They didn't give us the weights that were dissolved first to produce 500 ml solution. They didn't give us the weights. So, but we are told that from the 500 ml solution produced, 25 ml of that solution was taken and diluted to 500 ml, giving a concentration of what? 0.025% weight in volume. So, since we are not given this weight of potassium permanganate, let's go down. Let's solve this from back. Let's solve it from back to the beginning, from the end to the beginning. Now, we are told that the solution, that the stock solution produced with this unknown weight of potassium permanganate, 25 ml of it was taken and diluted to produce concentration of this and volume of this. So, going by dilution formula, remember, solution. Remember, the dilution formula says that C1V1 is equal to C2V2. From here now, we don't know the concentration of the stock solution formed using potassium permanganate. We don't know the concentration. So we call it C1. So C1 is what we are looking for. We know V1 because the volume that was taken from it is 25 ml. We know C2. C2 is the concentration of diluted solution, which is this. And we know V2, which is the volume of the diluted solution, which is what? 500 ml. So we are looking for what? C1. So C1 is now equal to what? C2V2 over what? V1. So, if that is the case, we now go over to the question and substitute these values with the parameters given to us. So TC2 is what? 0.025% weight in volume times V2 is what? 500 ml. All over V1 is what? 25 ml. So C1 is this. So, without wasting time, of course, ml will cancel ml. So we have something like this. Watching my calculator, we have something like this. 0.025 times 500 divided by what? 25. So we have 0.5% weight in volume. So C1 is 0.5% weight in volume. That's the C1. So unknown weight of potassium permanganate was dissolved in water to produce 500 ml of solution. And the concentration of that solution is what? 0.05%, 0.5% weight in volume. So let us interpret this 0.5% weight in volume. 0.5% weight in volume means 0.5% weight in volume means 0.5 gram of potassium permanganate in 100 ml solution. Since 0.5% mean weight in volume means 0.5 gram of potassium permanganate in 100 ml solution. Now, let us now find out how the amount of potassium permanganate that will be in what? 500 ml. Remember. So that means X would not be in what? 500 ml. So we find S. We find what? X. So let's go back. So if now cross multiply, we have something like this, that X is now equal to what? 0.5 gram times 500 ml all over 100 ml. So ml will cancel, of course this will cancel this. 0.5 gram times 5 is 2.5 gram. 2.5 gram. So the answer to this question is 2.5 gram of potassium permanganate. So what it means is that if you weigh 2.5 gram of potassium permanganate and dissolve it in a small amount of water and make it up to 500 ml with water. Then from there, if you take 2.5 ml and also make it up with water to 500 ml, it will produce a solution that has concentration of what? 0.025% weight in volume. So the answer is what? 2.5 gram of potassium permanganate. 2.5 gram of potassium permanganate. Before we move to the next question, please, if you have any question on this, feel free to call. Call for clarification. I will give 3 minutes for that. 3 minutes, then we move to the next question. I'm waiting for your calls. The number is 08138682003. 08138682003. You can also call 07012945891. Any of them, any of these numbers, call to ask your questions for clarification. Okay. We have 2 more minutes to go. Please ask your question if it is not clear. One minute to go. Go through what you put down while when I was solving the question, and check if there is anything that you are missing or anything you didn't get, so I can explain more. Place your call. Okay. Excuse me. Hello? Yeah, good afternoon. Okay. To convert what? So it's simple now. One gram is equal to 1,000 milligram. Remember, it's simple. 1 gram is equal to 1,000 milligram. I think we got let's assume you have 0.5 gram. If 1 gram is, hope you can see me. Can you see what I'm doing? Okay. If 1 gram is 1,000 milligram, 0.5 gram is now what? We call it X. We cross multiply. X is now equal to 0.5 gram times 1,000 milligram. Remember, 0.5 gram times what? 1,000 milligram. All over what? 1 gram. So gram will cancel gram. So this is one now is not significant here. 0.5 times 1,000 milligram. I think that was 0.05 or so. 0.05 grams. So that means 0.05 gram, 0.05 times 1,000 milligram is 0. What? Is 50 what? 50 milligram has gone. Is 50 milligram. Is it clear now? Okay. Okay. All right. Okay. So let's go over to the next question. Okay. So okay. Excuse me. Okay, let's look at this question. Let's look at this question. the question says, ephedrine sulfate. This is a question that has to do with isotonic solution. Please listen carefully and watch. Please, any step, if I take any step you don't understand, call immediately and ask questions. Don't wait till the end. Once I take a step you don't understand, call immediately and ask your question. I will explain, please. The phone line is on. Ephedrine sulfate, 0.3 gram, sodium chloride, QS, sufficient quantity. Purified water, add, that is to 30 ml. Make isotonic solution. Senior, using the what? Eye, to be used in the eye. The question now says, how many milligrams of sodium chloride should be used in compounding the prescription above? The E value of ephedrine sulfate is 0.20. Now, for us to solve this question, remember the colligative properties of a what? Solution. We have the osmotic pressure, we also have freezing point depression, we have boiling point elevation, and we have vapor pressure depression. But the one that are of utmost importance for us in determining the tonicity, the isotonicity, the tonicity of a solution is what? We have the osmotic pressure and the freezing point depression. Now, but this particular question now has to do with osmotic pressure. Now, even though it's not pressure as indirectly, but the pressure exerted by the concentration of the what is it called, of the solute in the what? Solution. Now here we have ephedrine sulfate, 0.3 gram. We have sodium chloride, sufficient quantity. Now, remember, it has been established that 0.9% weight in volume of sodium chloride solution is isotonic because it depresses the freezing point of water by 0.52 degrees Celsius. That means 0.9% weight in volume of sodium chloride solution has a freezing point of minus 0.52 degrees Celsius. And this is exactly the freezing point of the what? The body fluid. Lacrimal fluid. Am I communicating? Now, so sodium chloride has been found because sodium chloride has been 0.9% weight in volume of sodium chloride has this property. They now use sodium chloride as a standard. So what they now do is that all the other ingredients will now find their equivalent of sodium chloride. That's what gave rise to this E value of ephedrine sulfate. So the E value of ephedrine sulfate is what? 0.20. What this means is that 1 gram of ephedrine sulfate has the same 1 gram of ephedrine sulfate has the same isotonicity with 0.2 gram of what? Sodium chloride, provided that they have the same volume in solution. That's the meaning. That 1 gram of ephedrine sulfate has the same tonicity with 0.1, the same tonic effect, so with 0.2 gram of sodium chloride. That means in sodium chloride, 0.2 gram of sodium chloride represents 1 gram of ephedrine sulfate. That's the meaning. Now be careful with the question like this. Sometimes you may see a question that doesn't even need that is even without this sodium chloride, the formulation is even isotonic on its own. So be careful. So what we should do for the first step to take is to determine without this sodium chloride whether this solution is even isotonic. Then if it is not isotonic, we'll now start looking for the amount of sodium chloride that we need to add extra to make it isotonic. So in trying to find out if this is actually isotonic without sodium chloride, let's take it up from there. Now, this is 0.3 gram of ephedrine in ephedrine sulfate in 30 ml solution. But we know that 0.9% weight in volume of sodium chloride is isotonic. That means 0.9% what? Weight in volume of sodium chloride is what? Isotonic. Remember the meaning of 0.9% weight in volume. It means 0.9 gram of sodium chloride in what? 100 ml solution. For us to be able to compare these two, we need to reduce this to 30 ml solution. Okay? Good. But before we do that, there's something I want us to do. Remember that ephedrine, this is 0.3 gram, is in what? 30 ml. In fact, the shortest way, the easiest way to do that is to simply remember that ephedrine sulfate is 0.3 in 30 ml. So we need to use this equivalent of ephedrine to know the amount of sodium chloride this ephedrine sulfate, this 0.3 gram of ephedrine sulfate represents. But let's conclude this first. 0.9 gram of sodium chloride in 100 ml is isotonic. So how many in 30 ml will be what? Isotonic. So we have X here. X is now equal to what? 0.9 gram times what? 30 ml. All over what? 100 ml. So X is now equal to what? Let's go. This will cancel this. So we have 0.9 times 3 is 0.27 divided by 10 is 0.027 because 9 times 3 is 9 times 3 is 27. Okay, sorry, this should be 0.9 times 3 is 27. So 0.9 times 3 is 2.7. So divided by 3. So this should be what? 0.27. This should be what? 0.27 gram. So 0.27 gram of sodium chloride in 30 ml solution should be what? Is isotonic. Is what? Isotonic. If 0.27 gram of sodium chloride in 30 ml is isotonic, let us know the amount of sodium chloride represented by this ephedrine. If we check it, we now know whether it's something with this 0.27. For this solution to be isotonic, if we convert this to sodium chloride using sodium chloride equivalent of ephedrine sulfate, it must give us 0.27 gram. If it's less than 0.27 gram, that means this solution is hypotonic. That means we need to add extra sodium chloride to make it equal to 0.27 gram, making it isotonic. But if after converting this to sodium chloride using this E value, and we realize that it's above 0.27 gram, that means it is hypertonic. So if you are given a question, test the question first before you know what to do. Some things can appear like this, it can be confusing. If you test it first and realize that it is isotonic, you simply say you don't need to add, answer will be you don't need to add extra sodium chloride because this solution is already what? Isotonic. But if it is above, if it's more than 0.27 gram, you simply say this solution is already hypertonic. You cannot, the only way to make it a isotonic is to you don't need to add extra sodium chloride. If you add extra sodium chloride, it will make it more hypertonic. So the only way out is to look for a way to make it what? Isotonic. But if it is less than 0.27 gram, you do what? You calculate the amount of sodium chloride you need to add to make it isotonic. Make it 0.27 gram. So let us do these things I just said now. Let's test it. This is ephedrine sulfate, 0.3 gram in 30 ml. But this is for sodium chloride, 0.27 gram in 30 ml. This is isotonic. So let's convert this ephedrine sulfate to sodium chloride. Remember I said I explained the meaning of this 0.2, E value being 0.2. Excuse me. Okay. Remember I have already explained the meaning of this E value being 0.2. What it means is that 1 gram of this ephedrine sulfate is equivalent to what? 0.2 gram of what? Sodium chloride. So, if 1 gram of ephedrine sulfate is equivalent to 0.2 gram of sodium chloride, remember all of them are, two of them are in this starting mix, so they have the same volume. So that means we now calculate how many 0.3 gram of ephedrine sulfate will now be equivalent to X what gram of what? Sodium chloride. So let's find this X. Let's find this X. Let's find this S. So that means X is now equal to what? We cross multiply. X is now equal to what? We cross multiply 0.3 gram times what? 0.2 gram all over what? 1 gram. 1 gram will cancel gram. 0.3 times 0.2 is what? This is 2 alone times 0.3 is 0.6. So 0.2 times 0.3 is 0.06 gram. 0.06 gram. So if you look at this thing now, if you convert this ephedrine sulfate to sodium chloride, it's simply what? 0.06 gram. But for this to be isotonic, it must be what? 0.27 gram. It must be what? 0.27 gram. But what the sodium chloride is represented here is only 0.06 gram. What do we do? This shows that without this sodium chloride, this solution is what? Hypotonic. So let's make it isotonic by bringing it up to 0.27 gram. And the only thing we can do is to find the difference between this 0.27 gram and 0.06 gram. That difference would present the amount of sodium chloride we need to add to make it isotonic. That is bringing it up to 0.27 gram. Having in mind that 0.27 gram of sodium chloride in 30 ml solution is what? Isotonic. Let's go. So the amount of sodium chloride needed is what? 0.27 gram minus what? 0.06 gram. So this, if we subtract this, we have 0.21 gram. 0.21 gram. So the amount of sodium chloride needed to be added to make this solution isotonic is 0.21 gram. But we are told to get the solve it in milligram. So that means let's convert this to what? Milligram. Let me go back here. Let's convert this to what? Milligram. So if you have to convert this to milligram, we now have, remember that 1 gram is equal to what? 1000 milligram. That means that 0.21 gram is equal to what? X. X is now equal to what? 0.21 gram times 1000 milligram all over what? 1 gram. So this implies that X is now equal to this. Gram will cancel gram. 0.21 times 1000 milligram is what? 210 milligram. So the amount of sodium chloride need to be added, 210 milligram. The amount of sodium chloride we need to add here to make this solution isotonic is what? 210 milligram of what? Sodium chloride. 210 milligram of what? Sodium chloride. So the answer is what? 210 milligram of what? Sodium chloride. So 210 milligram of sodium chloride should be used in compounding the above what? Prescription. 210 milligram of what? Sodium chloride. Please, I want to give another 3 minutes. If you have any question, feel free to ask. The phone line is on. Remember the phone line, the number 0.08138682003 or 07012945891. All right. 3 minutes. Ask your question. Excuse me. All right, ask your question. We have 2 minutes to go. Ask your question. Feel free. Okay, let's go to the next question. While we wait for question, let me clean the board and write the next question while we wait. Okay. Let's look at this question. The question says, if 150 ml of sorbitol solution weighs 170 gram, what is its specific gravity? If 150 ml of sorbitol weighs 170 gram, what is its specific what? Gravity. This thing means specific what? Gravity. Remember that specific gravity of a substance is defined as the ratio of the weight of the substance to the weight of equal volume of a given what? Standard. The standard can be water, it can be hydrogen. If the substance in question is a solid or a liquid, the standard is water. But if the substance in question is a gas, the standard is what? Hydrogen. Then what do I mean by weight of equal volume of a particular standard? Weight of equal volume means the weight of that substance that has the same volume. I mean the weight of the standard that has the same volume with the volume of what? That has the same volume with the what? The substance in question. Let me use sorbitol as an example. Sorbitol, the standard is water. So the specific gravity of sorbitol is simply weight of sorbitol over weight of equal volume of what? Water. With respect to sorbitol, weight of equal volume of water means weight of water that has the same volume with what? Sorbitol in question. Now with this at the back of our mind, let's solve this question. We are told that the sorbitol has volume of what? 150 ml. Sorbitol, 150 ml of sorbitol solution weighs 170 gram. So the weight of sorbitol solution is 170 gram. Why its volume is what? 150. We are told to find the specific gravity. So going by our definition, solution. So specific gravity of sorbitol is now equal to weight of sorbitol solution over weight of equal volume of what? Water, because water is the standard in this case. Now, weight of sorbitol solution we are given is 170 gram. And the volume of sorbitol is what? 150 ml. So, we don't know this. This is what I'm looking for. But we know this. We don't know weight of equal volume of water. But we know that the volume of the sorbitol is what? 150 ml. Since the volume of the sorbitol, question if you have any, or in the absence of any question, after 2 minutes, I'll move over to the next question. Okay, let's go over to the next question. Excuse me. Okay, let's go over to the next question. Okay. Let's look at this question. These questions 1, 2, 3, 4, 5, 6 questions. So if we solve these 6 questions, then we round it off here to continue next week. All right, let's look at this question. Question says, approximate the quotient of 10.2 divided by 3 to the nearest tenth. To the nearest what? Tenth. So you simply divide 10.2 by 3. If you divide 10.2 by 3, if you divide 10.2 by 3, if you divide 10.2 by 3, you have, we have 3.4. If you divide 10.2 by 3, you have 3.4. You have what? 3.4. The question says we should approximate to the nearest tenth. You know, in the place values, we have units, we have moving from let me align them in this form. We have this is the units. We have 10, then we have tenths. We have unit 10, we have 100, we have hundreds, we have thousand, we have thousand, we have thousands. So the same way, if you now put it in exponential notation, this unit is 3 raised to power 0, y10 is 3 raised to power minus 1, 100 is 3 raised to power minus 2, 1000 is 3 raised to power minus what? 3, 10 is 3 raised to power 1, 100 is 3 raised to power 2, 1000 3 raised to power what? 3. Now if you look at 10 3 raised to power minus 1, this number is already has 3.4. It's in the tenth already. So there's nothing you can do here. So if you divide 10.2 by 3, it will give you 3.4. You not do any other thing there again. It's what? 3.4. That's the answer. You cannot do anything because it's already in tenth. It's already in what? Tenth. So the answer is 3.4. Then approximate the product of 2.5 times 6.42 to the nearest integer. To the nearest integer. If you multiply this, we have 2.5 times 6.42. We have 2.5 times 6.42. We have 16.05. 16.05. But we are meant to leave it to the nearest integer. So if you approximate, 16.05 is not an integer. If you move this one and call it 1, it comes here. 16.1 is also not an integer. 1 here is not to 5, so you cannot move 1 here. So everything here will go because this one, the 1 here, 1 that came from this 5, it's not up to 5 for it to move here. So everything from here will go. So the answer is simply what? 16 to nearest what? Integer. 16 is an integer. So this is nearest to what? Integer, 16. So the answer to this question is 16. This one says approximate 38.47 to the nearest 100. Remember what I said about 100. So if you watch now, just like as we have here, this thing now means 3.0 plus what? 0.4. This one is in tenth because it's 3 raised to power minus. The place value is 3 raised to power minus 1. Here now, if you look at this one now, you have that this is 10. No, this is 10. This is unit. Decimal point. You have tenth, hundredth. Here, this is units, decimal point. To left, to this side, we have tenth. So here is 10 units, decimal point, tenth, hundredth. So this 8.47 is already in hundredth. So you cannot do anything about it again. So the answer is still what? That's 8.47 to the nearest hundred. So you won't change anything there. Now let's go to this question. This question says approximate 9.894 to the nearest tenth. Now this one, let's do this one. We have 9.894. Let's start from here. This is not up to 5, so it will go. This is 9. Here, okay, basically here is units. Here is tenth, hundredth, thousandth. Now here is thousand. We are looking for what? Nearest tenth. So we should stop here. So we move here. This 4 is not up to 5. It will go, and nothing will be added here. 9 is more than 5. So we round it up and now get to carry one from here and put here. It becomes 9. So we have 9.9. It's approximately what? 9.9. This is unit and this is tenth. So to nearest tenth, the answer is what? 9.9. Okay, let's go to this question. This one says approximate 58.888 to the nearest integer. 58.888 to the nearest integer. Now let's go. Basically, this is 5, this 50, this is what? 10, this is unit, decimal point, tenth, hundredth, thousandth, tenth, hundredth, thousandth. We are told to leave it to the nearest what? Integer. So whatever we are moving here should be here, at least. Should stop here. So let's go. Here is 8, is up to 8, is up to 5. So we move it, we'll take it away and add 1 here. Here becomes 9. It's also above 5. We take it away and add 1 here. Here becomes 9. We are not stopping here. We are stopping at the what? Nearest integer. So we move it one. We move this one away again. Take 1 there and add here. It becomes what? 59. So the answer is what? 59. So to the nearest integer, the answer is what? 59. Now, last question says, estimate the quotient of 98,000 divided by 49. Estimation is not the same thing with calculation. So we are not doing any calculation here. We just look at it, their place value, and estimate them. So look at this one here. This is 98. This is 98. If it's okay, if this 98 is 8 is above 5. We can round this 8 off. Add it here, become 10. So here becomes what? Here becomes what? 10. Here becomes what? 10. And here we call it 0. Remember, 10, 0. 0, 0, 0. Here we can move it. Call it 0. Here becomes what? Add it 1 here. Here becomes 5, 0. 0 will cancel 0. 5 will divide. This is 10,000. 5 divided 10,000. We have 2,000. So this is estimated to be what? 2,000. This is estimated to be what? 2,000. Yeah, correct. This will take care of this one. So we have 10,000. So 5 divided 10, 2. 1, 2, 3 is 2,000. So the quotient of this estimated is what? 2,000. It's also the same thing with the actual value, if I'm not mistaken. All right, so these are the answers to these questions. I don't know if you have any question, please feel free to ask. We've come to the end of today's lecture. Please, I'll give few minutes to entertain question. Any question you can ask, you mustn't be on this one we saw. Any question you can ask, feel free to call and ask the question. We have 5 minutes to do that. So while we wait for questions, I want to announce to us that every Sunday, 3 p.m., between 3 p.m. and 5 p.m., we'll be having our pharmaceutical calculation lectures. Please, let's plan for it. 3 to 5 p.m., pharmaceutical calculations. Please, I want to remind us that every Saturday, 7 a.m. to 7:10 a.m., I organize academic competition. I titled Academic Battle with Pharmaceutical School Board. It features different subjects from art, science, commercial courses, medical courses. And the flyers is all over my social media platform. If you go to my YouTube channel, it's there, Pharmaceutical School Board. Please subscribe to this YouTube channel. If you go to Facebook, Pharmaceutical School Board is also there. Twitter is there, Pharmaceutical School Board. Instagram is there. And if you have any question, you want to make more inquiries, please chat me up on this number, 08138682003, 07012945891. We also organize other lectures on daily basis on this YouTube live. Basic sciences, English, chemistry, physics, biology, mathematics, even English language. Then we also have pharmacology courses and the dispensing, then pharmaceutical calculation. Any of this we are interested in, please chat me up so that I'll give you the dates. Okay, so for the academic competition, if you are interested, chat me up. Registration is free of charge, and there are prizes to be won. Of course, the topic you will read, you will study for the competition will be given to you. So I don't know if there's any question. In the absence of any question, we end it here. Please, for those preparing for examination, please, for pharmaceutical calculation examination, please listen to these lectures. Even after this live presentation, still go back to the lectures because it will be there on YouTube. Study it, watch the lecture all over and all over again, make your notes from it, and prepare yourself for the examination. Success in your examination, and God bless you. See you next time.